So hello students, in last class I have discussed about the refraction and convex spherical surface. Okay, I just forgot to write one thing. In last class I have derived the expression for refraction and convex surface when the object, I have forgot to write this point, when the object is lies in rarer medium and image is from real. Okay, in last class. So just write this. Now today we will discuss about the object we place in rarer medium, but the image is from is virtual. Okay, here the image will form at image form is virtual. Okay, so we consider this one convex spherical surface. This is rarer medium mu1, we referring to as mu1, and this is denser medium, we referring index mu2. Okay, we take one point object O. Okay, from OA is the incident ray, incident at the point of convex surface at point A, and after reflection it will go along the AQ. It will go along the AQ. Okay, now if you see, then this ray will not meet in this side, so we have to, but if you see from here, then we can appear to come from this point. So we will extend this reflected ray by dotted line in this point. Okay, now one more ray is along the principal axis. It is also, suppose it is come from here, consider along the principal axis. We know that ray which are along the principal axis, it will not change its path after refraction. So these two rays, if you see, this ray and this ray will virtually meet at this point. If you extend this, virtually meet at this point. So I is the virtual image of point object O. So I am telling once again, these two rays are virtually made at this point on the same side of the object. So I will be the virtual image of point object O. Okay, so here P is the pole. We draw A in normal and NC in normal to the center of curvature. Here C is the center of curvature. Okay, now we will derive this equation. We will derive our equation. First of all, okay, so this angle, if this is normal, this is incident ray, so this angle will be the I, and this is reflected ray, this is normal, so this angle will be the R. This angle will be R. Okay, first we consider, suppose we consider this is triangle AOC. This AOC. So from triangle AOC, so here I is the exterior angle and alpha and gamma is the opposite interior angle. So we can write I equals to alpha plus gamma. Alpha plus gamma. Okay, again okay, alpha and gamma are very small. Practically the alpha and gamma we want to consider, then alpha and gamma are very small angle. So for very small angle we can write alpha is almost equals to 10 alpha and gamma is almost equals to 10 gamma. So it will be I equals to 10 alpha plus 10 gamma. 10 alpha plus 10 gamma. Okay. Now what is 10 alpha? If you consider this triangle AON, what is 10 alpha? 10 is perpendicular by base. So here perpendicular is N, and what is base? It will be ON. So AN by ON. And what is 10 gamma? ANC. Consider triangle ANC. 10 gamma will be AN by NC. AN by NC. So I equals to, we can write I equals to, so this aperture is small, aperture of this convex spherical surface is small, so this end point is lies very near to, we can say that this end point is lies very near to point P, this end point. Okay, because the aperture is small, so the distance is negligible. This distance is from N to P is negligible. So we can write N, I equals to N in place of ON. We can write OP. Okay, we can write OP, and in place of NC, we can write PC. We can write PC. So you give it equation number 1. Give it equation number 1. Okay. Give it equation number 1. Now, okay. So let me. I will erase this. Okay. Again, suppose we consider. Now consider from triangle. Suppose we consider triangle. Now we consider triangle AIC. This one AIC. This triangle. Okay, so in this triangle, R is this angle of refraction, R is the exterior angle, and beta and gamma is the opposite interior angle. So we can write R equals to beta plus gamma. Beta plus gamma. So again we can say that beta and gamma is very small. So we can write R equals to 10 beta by 10 gamma. What is 10 beta? We have to write this. Okay, I am just writing here directly. So when you write your notes, we have to write this. Why this beta 10 beta equals 10 beta and alpha gamma equals 10 of gamma. Okay, I have already discussed. That's why I have not written here. Okay, now see. Now beta equals to 10 beta plus gamma equals to 10 gamma. Now what is 10 beta? Consider this triangle AIO. 10 beta will be N by Ni. And what is 10 gamma? 10 gamma will be N by NC. N by NC. So it will be N by Pi plus N by PC. R equals to. Give it equation number 2. Give it equation number 2. Okay. Now we know mu equals to mu 2 by mu 1. Okay. And mu equals to sin I by sin R equals to mu 2 by mu 1. Again, I and R also is small. I and R also is small. So for a small angle, we know already the sine of ratio of that angle equals to that angle. That means if I is small, so sine I equals to, we can write I, as if R is very small, then sine R equals to R we can write. So we can write this equation as I by R equals to mu 2 by mu 1. So I mu 1 equals to R mu 2. Okay. Now we have to put this value. We have to put the value of I and R. What is I? Mu 1 into I means N by OP plus N by PC. That is equals to mu 2 into what is R? N by Pi plus N by PC. N by PC is OP. This is PC. Pi PC. Okay. So let me use this. Now, okay. Okay, so here we can write an will be cancelled, so mu1 1 by OP plus 1 by PC equals to mu2 1 by PI plus 1 by PC 1 by PC 1 by PC. Now if you are using sign convention, so what will be the OP? You suppose it is imagine D and it is R. What is OP? If you are using sign convention, OP will be minus U because we have taken in the opposite direction of the incident ray. PI will be minus B and PC will be plus R. PC will be plus R. So if you put this value here, mu1 1 by minus U plus 1 by R equals to mu2 1 by minus B plus 1 by R. Okay, so it will be minus 1 by U into 1 by U into mu1, sorry, that's right, mu1 by U plus, if you just come this mu2 by V, if you take common mu1 by R, then it will be mu2 minus mu1, mu2 minus mu1, mu2 minus mu1. So just divided by mu1 in both sides, so it will be 1 by U plus, here mu2 by mu1 will get mu2 by mu1, so it will mu2 by mu1 is mu by V equals to 1 by R, mu2 by mu1 is mu, and mu1 cancel, it is minus 1. So this is the equation for refraction through convex spherical surface when the object lies in rarer medium and image from is virtual. It is same like the previous one. Okay, it is same by the previous one, minus 1 by U plus mu by V equals 1 by R, mu minus 1, mu minus 1. Okay, so just go through this little lecture and try to find a relation for where refracting through convex spherical surface when the object lies in denser medium. Okay, try for it when it is the object lies in denser medium, that means in this side. Okay, so for today that's all. So thank you.